Example 12. 500 cm cube of oxygen was collected over water at 30 degrees centigrade and 75 mm mercury pressure. What is the volume of the dry oxygen at STP? Water vapor pressure at 30 degrees centigrade equals to 32 mm of mercury. Solution. Pressure of the dry gas equals to measured pressure minus water vapor pressure, which is equals to 752 minus 32 mm of mercury, which will give us 720 mm of mercury. Using the formula P1V1 over T1 is equal to P2V2 over T2, we get V2 equals to P1V1 over T1 times T2 over P2, where P1 is equals to 720 mm of mercury, V1 is 500 cm cube, T1 is 273 Kelvin, T2 is equals to 273 plus 30, which will give us 303 Kelvin. P2 is equals to 760 mm of mercury. On substituting V2, we have that 720 times 500 times 273 all divided by 760 times 303, which will give us 426.8 cm cube. Chapter 7. Gaylussac's Avogadro's law and molar volume of gases. Gaylussac's law of chemical combination by volume. Gaylussac's law states that when gases react, they do so in volume which bears a simple ratio to one another and to the volume of the product if gaseous, provided temperature and pressure are constant. Example: 1 volume of nitrogen plus 3 volumes of hydrogen will give 2 volumes of ammonia. 1 volume of hydrogen plus 1 volume of fluorine to give 2 volumes of hydrogen chloride. 2 volumes of hydrogen plus 1 volume of oxygen will give 2 volumes of steam. Example: 10 cm cube of carbon 2 oxide were mixed with 15 cm cube of oxygen and explode. After cooling to the original temperature, the volume was 20 cm cube. After shaking with aqueous sodium hydroxide, the volume is reduced to 10 cm cube. Show that this figure agrees with Gaylussac law. Note 1. When gases react at high temperature and the temperature is lowered, any vapor form condenses into liquid water and therefore exists no pressure and has negligible volume. 2. Whenever carbon 4 oxide is formed or is evolved in a reaction, the addition of aqueous sodium, ammonium or potassium hydroxide or any other alkaline or base is to remove carbon 4 oxide. This is possible because acidic carbon 4 oxide is neutralized by the base. Solution. The volume of carbon 2 oxide before sparking is equal to 10 cm cube. The volume of oxygen before sparking is 15 cm cube. After the reaction, all carbon 4 oxide formed was removed by addition of sodium hydroxide. All the carbon 2 oxide was used up. Therefore, residual excess gas was oxygen, which is equal to 10 cm cube. Volume of oxygen that reacted is equal to 5 cm cube. That is initially 15 cm cube minus 10 left over 10 cm cube. Volume of carbon 4 oxide formed equals the amount removed by adding sodium hydroxide, which equals to 20 cm cube minus 10 cm cube left, which will give us 10 cm cube. Value of excess of oxygen has been used to ensure that all the carbon reacted. We can, from the reasoning above, write 10 cm cube of carbon 2 oxide react with 5 cm cube of oxygen to give 10 cm cube of carbon 2 oxide. Ratio of reacting gases and products in bracket divided by the lowest volume 5 cm cube. So carbon 2 oxide plus oxygen we give carbon 4 oxide, that is ratio of 2:1:2. These are similar ratios as given by Gaylussac's law. Example 2. 50 cm cube of hydrogen is packed with 20 cm cube of oxygen at 100 degrees Celsius and 1 atmosphere. What is the total volume of the residual gases? Solution. Chemistry of the reaction. Hydrogen reacts with oxygen to give us water. Combining volume, 2 volume of hydrogen combined with 1 volume of oxygen to give 2 volume of water. Volume before sparking, 50 cm cube of hydrogen combined with 20 cm cube of oxygen while no volume of water was given. Expecting volume after sparking, 40 cm cube of hydrogen react with 20 cm cube of oxygen to give 40 cm cube of water. Therefore, the total volume of residue gas is equal to 10 cm cube left over from the 50 cm cube of hydrogen plus 40 cm cube of water, which will give us 50 cm cube. Note, at 100 degrees centigrade and above, water is in form of steam. Example, 10 cm cube of carbon 2 oxide is mixed and sparked with 100 cm cube of air containing 21% oxygen. If all the volumes are measured at STP, calculate the volume of the resulting gases. Solution. Volume of oxygen present in 100 cm cube of air is equal to 21/100 times 100, which gives you 21 cm cube. Volume of nitrogen and the rare gases present in 100 cm cube of air is equal to 100 minus 21, which will give us 79 cm cube. These did not react. Chemistry of reaction. Carbon 2 oxide reacts with oxygen to give carbon 4 oxide. Combining volume, 2 volume of carbon 2 oxide reacts with 1 volume of oxygen to give 2 volumes of carbon 4 oxide. Before sparking, 10 cm cube of carbon 2 oxide reacts with 21 cm cube of oxygen, where the carbon 4 oxide volume was not given. After sparking, 10 cm cube of carbon 2 oxide reacts with 5 cm cube of oxygen to give 10 cm cube of carbon 4 oxide. Excesses of oxygen, it was 16 cm cube, that is 21 minus 5 cm cube. Therefore, the total volume of the resulting gas is equal to 10 plus 16 plus 79. That is the volume of nitrogen and air gas present, which will give us 105 cm. Avogadro laws. Avogadro's law states that equal volume of all gases under the same temperature and pressure contain the same number of molecules. This means that 100 cm cube of each of the following gases: ammonia, the nitrogen oxide, oxygen, carbon 4 oxide, and sulfur 4 oxide at the say 20 degrees centigrade and 739 millimeter pressure, contain the same number of molecules. By Avogadro's law, the volume can be changed to moles. Therefore, when oxygen and hydrogen react as follows: hydrogen plus 2 moles of hydrogen plus 1 mole of oxygen to give